The switch on the left is representative of the magnetic contact type, being the first and still most common in use. All of the high security switches that followed are some variation of this basic concept. Here are some examples of currently used components. The high security switch on the right implements a novel magnetometer. An onboard computer analyzes the magnetic field in 3D using a proprietary numerical method. This device does not use Hall switches and comparators. This is smart technology. Here are some examples of smart chips and sensors. The primary flaw of the classical BMS is its susceptibility to trivial defeat. This example of a defeat stick is very simple, with a complete explanation published in the Journal of Physical Security. Here, we replace the original magnet with a special defeat stick roughly 1/8 of an inch thick. The classical BMS is no longer any obstacle to a professional intruder. All magnetic contacts of whatever type are defeatable by trivial means. This example reroutes the magnetic field through a high permeability shunt into the gap. The implication that UL 634 Class II devices cannot be defeated only needs one example to render it invalid. Here is the proof. Now, we compare the classical BMS failure modes with the Jackson magnetometer. The failure modes in the table are false alarms from vibration and impacts, false alarms from EMI such as lightning, failure to make, failure to break or contact sticking, and susceptibility to trivial defeat. All magnetic contacts have these problems despite any advertising claims to the contrary. The Jackson magnetometer has no magnetic or electrical contacts of any kind and specialized circuitry, making it invulnerable to all of the above. Magnetometers measure complex magnetic fields. There are many different types of magnetometers. Some examples are shown here. The Jackson magnetometer sees three-dimensional vector magnetic fields in real time. The 3D image it sees must be analyzed and processed in real time to be useful. This requires an onboard microcomputer. Proprietary numerical methods allow the sensor to recognize its own magnet. The sensor will reject any other magnetic field. The Jackson magnetometer high security switch combines a magnetometer with an onboard computer. This satellite technology packed into a black box yields the most advanced high security sensor ever developed. Turn the switch on and observe the test cycle. Green indicates secure, red indicates alarm. Moving the magnet too close triggers an alarm. Now we test vulnerability to the defeat stick. The defeat stick has no effect. Next, we initiate self-test when the switch is secure. Then we initiate self-test when the switch is in the alarm state. Notice the light flashing sequence in each case. Now we disconnect the switch and connect a dummy switch cable to the tester. The switch signal lines are shorted to power ground to indicate that the switch is secure. Initiate self-test. You can see the flash sequence is absent and self-test fails. Reconnect the switch and observe auto self-test. This is the most advanced high security sensor ever made.